Hello everyone, this is Mr. McMillan. I'm here with a instructional video on arc length and sector area. But before we begin talking about the arc length and sector area, we are going to be talking about the circumference and area because we need to know how to find those in order to find the arc length and sector area. So your circumference and area you've talked about in previous classes. The circumference of a circle is defined as the linear distance of a circle's edge. So in other words, it's the distance around the circle. So if you look here, there's this arrow here outside of the circle. That would be our circumference. Okay, so we have this edge here. We go around it. That is our circumference C. Okay. This is similar to perimeter and polygons, but instead of adding the sides together, there's a formula we use in order to determine our circumference. So their circumference is given by one of two formulas, and they both give you the same exact thing, but they're just presented a little bit differently. So the first is that the circumference is equal to 2 times pi times r. So C equals 2 pi r. Okay, so if you know your radius, you plug it in here, multiply it by 2 pi, and that gives you your circumference. The other thing that you can do is that you can use the formula C equals pi d. Okay, pi times d. Now the reason we can say pi times d is because 2 times the radius is equal to the diameter. So we replace the 2r with d and keep the pi around, and these two are equivalent. Okay. Now I would highly recommend using the radius version of the circumference for the exact reason that if you know your diameter, you can find your radius, and if you already know your radius, then you can just plug it straight into the formula. But there's another reason, and that's because of the formula for the area of a circle. The area of a circle is determined by the amount of space inside the circle. The shaded section in the diagram below is considered the area, so it's this entire thing. Okay, so the area is given by the formula A equals pi r squared. While we could make an equivalent that has d squared instead of r squared, the much simpler formula is pi r squared. That's the one you've heard of in previous classes before. Okay, so pi r squared and 2 pi r. This is the reason that I choose to find my radius in all situations, because if I want to find the circumference and the radius, I can always use 2 pi r or pi r squared instead of having to worry about pi d. Okay, so let's look at number 1. Number 1 says, what is the circumference and area of a circle with a radius of 16 feet? So it wants to know the circumference and the area. So we're going to be using both of those formulas, and it gives us the radius of 16 feet. So that means that r is equal to 16 feet. Well, we already have r, and both of our formulas have a version that has the radius in it. So we're going to find our circumference first, then our area. So the circumference is equal to 2 pi r. So 2 pi drops down, and we plug in our r, and we get 16 for r. Now, pi is a number, but typically what it wants us to do is to determine the area or circumference using exact answers. So that's going to have pi in it because pi is an irrational number. It's 3.14 and then onwards. You know, we don't know if it has an end, but it, you know, it's irrational. So what we're going to do is treat pi like a variable and multiply these two numbers instead. So we have 2 times 16, which gives us 32. And then the pi drops down. So our exact circumference is equal to 32 pi feet. Okay. So if it wants an exact answer, your answer needs to have a pi in it. So all you would do here is just multiply your numbers and leave the pi alone and drop it down. Okay. In the event that it does require you to round it. Now I know I'm about to use 3.14 instead of pi, but Desmos will have a pi button on it. Okay, so use Desmos for that. So if you take 32 times 3.14 and you wanted to round that to say the nearest tenth or the nearest hundredth, that would be approximately 100.5 feet. Okay, so some answers will want you to round it, some answers will want you to give exact values. All right, now let's look at the area. So our area is given by the formula pi r squared. And we already know r, so we plug that in. So pi times 16 squared. We do our 16 squared first. So 16 squared is 256, and the pi drops down. So our area is equal to 256 pi feet squared. And that's how you determine the circumference and the area. So let's look at number 2. Number 2's got a picture along with it. It's got a circle there. And it wants us to determine the circumference and area again. So look here. What do you notice about that 24? Well, that 24 goes all the way across the circle. That 24 is the diameter. So D equals 24 meters. Well, remember how I said I always want to find my radius first? Well, we know that the diameter is twice the length of the radius. So if our diameter is 24, we know our radius has to be equal to half of that, which is 12. So now that you have your radius, you can plug them into your equations or your formulas. And so we have C equals 2 pi r for our circumference, which in this case is 2 pi times 12, which is 24 pi. So 24 pi is our circumference for number 2. And then our area is given by pi r squared. So we plug in the 12 into r because we already know our radius. And we get that 12 squared is 144, and then the pi drops down. So our area is 144 pi meters squared. Okay? So now what I want you to do, I want you to pause the video and I want you to try to determine the circumference and area for numbers 3 and 4. Then come back to the video and check to see if you're correct. So on number 3, it says, look at the circle below. What is the circumference and area? And in this one, instead of like number 2, where it gives us the diameter, this time it already gives us the radius. So r is equal to 7. So our circumference is given by the formula 2 pi r. So we have 2 pi times 7. 2 times 7 is 14, and the pi drops down. So our circumference is 14 pi inches. Then our area is pi r squared. Plug in the 7. And you get that pi r squared ends up being 49 pi. Remember that squaring a number means you multiply it by itself. So 7 squared is 7 times 7. Number 4, it says, what is the circumference and area of a circle with a diameter of 12 centimeters? So it gives us the diameter. I want to find my radius first. So the radius is half the length of the diameter. So we take the diameter and divide it by 2 to get our radius of 6 centimeters. Now we want to find our circumference and area. So our circumference is C equals 2 pi r. Our r is 6, so 2 pi times 6. So 2 times 6 is 12, and then the pi drops down. That's our circumference. And now we look at our area. Our area is given to us by pi r squared. So we plug in r, which is 6 squared. 6 squared is 36. The pi drops down, so our area is equal to 36 pi. Okay? And that's how we determine the circumference and area of circles. Now, what we can do with that is we can determine what the arc length and sector areas of specific arcs and sectors are. Okay? So the first thing we're going to look at is the sector area. And a sector, we talked about this in the diagram with the circle parts, but we're going to reiterate it here. A sector of a circle is the part of a circle that is enclosed by 2 radii of a circle and their intercepted arc. Okay, so a sector of a circle is enclosed by 2 radii. Okay, these are pie-shaped pieces of the circle. Some people think of pizza, cake, pie, whatever circular thing you have that splits something evenly or into parts. But the most important thing is that the area of a sector is a fraction of the area of a circle. So in other words, there's got to be some fractional amount that the area of a sector is compared to our original area, to the whole thing. Okay, so the sector is only going to be part of it. It's not going to be the whole thing. So if we look here at our diagram, we have our radius, and you'll see here that this shaded area is enclosed by the 2 radii. Now you would also have it be one here. This white space would be a larger sector, so you could do that, but we'll get into that more as we continue along. So if we want to determine a formula for the sector area, what we're going to be using is this theta. And this theta is the central angle. And the important thing about that central angle is that that angle determines the degree measurement of the arc. Well, do you remember how we talked about that the degree measure of a circle is 360 degrees? So that's our whole thing. Now, we only have this tiny part of it, this central angle theta. So our fraction of what this angle is to the whole thing is theta over 360. And since we're looking for sector area, and the area of a sector is a fraction of the area of a circle, we take that fraction that we found there, which would be the part, the proportion that the angle would be, and then we multiply it by our area, which is pi r squared. So we take our theta, divide it by 360, and multiply it by by pi r squared. Okay? So let's look at number 1. Number 1 wants us to find the area of the shaded section below. And you'll notice here, it's hard to tell a little bit, but you'll notice here that there is a 162 degree angle there. Okay? Now, this is inside of that sector. It's inside that shaded part. So this is going to be our theta. So theta is equal to 162 degrees. That is our central angle. Now, what is our radius? Because we need theta and we need radius for each one of these types of problems. Well, our radius, as we can see here, is going to be 18 centimeters. So we have theta, we have the radius. So now we just plug it into our equation. So theta over 360, so 162 over 360 times pi and then r squared. Well, r is 18 squared. So this is what you would type into your calculator to determine a rounded answer. Now, if you want to determine the exact answer, go ahead and bring out that pi. Okay, so you're going to have pi back here, and we need to figure out what's going to be in front here. So let's go to Desmos and look at that, if my camera will ever work. All right, so we are going to type in 162 over 360. Then we're going to hit the right arrow key or click away from it so we're outside of it. And then times. Now remember, we're going to keep that pi. We've already dragged it out. So the only thing left is to multiply this by 18 squared. And you'll see that we get 145.8 as our number that would go in front of the pi. So technically that's an exact answer. But remember, what we can do is we can simplify this into the appropriate fraction. So if we click this button here, it will simplify our decimal into the most simplified fraction, okay? So your simplified fraction would be 729 over 5. So you could write this answer in one of two ways. So going back to what I have written on my paper, you could write it as 145.8 pi or 729 over 5 pi. Okay, so I'm going to write it as the fraction because that's what you tend to see in problems anyway. All right, now let's look at number 2. It says James cuts a cake into 10 equal pieces. If the cake had a diameter of 16 inches, what is the approximate area of each slice? Now you'll notice there it says approximate area, so this is where we're going to round. So he cuts a cake into 10 equal pieces. So if you draw that out, and I'm going to draw it out as best I can. If you've seen anything else that I've done, you know that I'm not the best at this. Anyway, imagine that those are equal, okay? So there's 10 equal pieces here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we know that the cake has a diameter of 16 inches. So first off, what I want to do there is I want to find my radius because it gives me the diameter. So the radius is going to be equal to 16 over 2, which is equal to 8. So I know my radius. But here's the thing. I always need my radius and my theta to determine a sector area. I don't have my theta yet. So how can I figure this out? Well, he cuts the cake into 10 equal pieces, which means that he's cutting this circle angle-wise into 10 equal sectors with 10 equal angles. All the angles have to equal the entire thing. Well, the entire thing for a circle is equal to 360. So if we want to determine what theta is, which would just be the 1, we take 360 and divide it by the number of slices, which is 10. And so we find that our theta is equal to 36 degrees. So now we have theta, now we have R, now we can use our sector area formula. So we put theta over 360, so 36 over 360 times pi times 8 squared. Now, I will tell you when you plug this in and go for it, 36 over 360 will give you 1 over 10. 1 over 10 times 8 squared is 64 over 10, which gives you 6.4 pi. Okay, so we're going to plug that all in to Desmos. And we're going to include the pi this time because it wants the approximate area. Okay, so I'm going to do it from the original and then, show you. So times and then pi, and then times 8 squared. And so our approximate area of each slice is 20.1 inches squared. And you can see that if we did 6.4 pi, we get the exact same thing. Okay? The other way you could have done that is you're looking for the approximate area of one slice, and you know it's 10 equal pieces, so you know each sector has to equal 1/10 of the original area, so you could just take 1/10 and multiply it by your area. But I tend to do this just to be consistent and show you how you could figure it out from there. All right, now let's look at the arc length, and this will be the last couple things we do today. There is a set of example problems. We will work more with those together during the next lesson. So our arc length, very similar formula to what the sector area formula is, just with a little bit of a different flavor to it. So the arc length of a circle is the linear distance of the arc of a circle. Arc length is always measured in units of length because it's a length, so feet, centimeters, miles, etc. This length is a fraction of the circle's circumference. So just like the sector area was a fraction of the area, the arc length is a fraction of the circle's circumference. Okay, because the arc length lies on the edge, as you can see here. Okay, so your equation here, guess what? You're going to end up with the exact same thing in front because you're looking at your theta, which is your central angle, and you're comparing it to the whole thing. So the first part of your equation for arc length will be theta over 360. But this time, since it's a fraction of the circumference, you're going to use the formula for circumference. So theta over 360 times 2 pi r. So let's look at a couple of example problems. Number 1, circle R contains a central angle QRS with a measure of 70 degrees and a diameter of 10 meters. What is the length of QS? So what we're going to do here, we're going to draw this circle. And we've got circle R in here. It says QRS is a central angle, so we've got something like this. And that's 70 degrees. And it says a diameter of 10 meters. So D equals 10. So just like sector area, we need two things. The first is we need theta, which is our central angle. And our second is we need the radius. Well, in this case, it gives us our central angle is 70 degrees. So theta is 70 degrees. And this time it gives us the diameter is 10. So we need to determine our radius. Our radius is half the length of the diameter. So our radius is 5. Now we just plug it into our formula. So we do theta over 360 first. So 70 over 360, and then multiply it by 2 pi r. So we do 2 pi times 5. So then all we do here is we simplify it. So we've got 70 over 360 times 2 times 5, which is 10, and that gives us 1.94 repeating, which as a fraction is 35 over 18, and then we tack on the pi at the back end. Oops. Okay. So the length of arc QS will be equal to 35 over 18 times pi. Now, if you wanted to approximate it, all you have to do is plug that whole thing into the calculator and round it to whatever it wants you to round it to, whether that be the 10th, the nearest whole number. Just pay attention to how the problem wants you to do it. Number 2, find the length of arc AB. This will be the last problem that we do here. And you'll see this is remarkably similar, except we don't have to draw the picture. So we need our theta and radius. And you'll see that your theta is equal to 68 degrees here. This is your central angle. And your radius is equal to 4. Plugging in our equation, we do theta over 360 first. So 68 over 360 times 2 pi r, which is 2 pi times 4. So you get 68 over 360 times 8 pi. And now you just multiply your 68 over 360 and your 8 together, and then simplify, and that gives you your arc length is 68 over 45 times pi. If you're going exact, make sure that you use that you have pi in your answer. Okay, approximately, make sure that you multiply by pi in the calculator. A lot of times the questions will just drop the pi and just have that. So if you forget to do that, they'll trip you up on that. So be careful with that. Okay. During the next video, we will go over these example problems. There's 8 of them here, just to make sure that you guys are ready for the next worksheet on this. In the meantime, work on those assignments that are posted. Thanks, guys, and I will see you in the next video.